Good morning. This is Mrs. Rondo. I'm going to walk us through our lesson for today. We're going to be talking about the exterior angle theorem. And actually, the exterior angle theorem is basically an applied version of triangle sum. So you can see our essential question, how can we apply the triangle sum theorem? And our learning goal is that we can prove the exterior angle theorem. And if you need more time here, go ahead and pause, but we're going to keep moving through. All right, so the beginning of this, I just wanted to review what you guys did in a previous video. It got brought up about different types of angles. So I just wanted to review that an acute angle, the measure of angle A here, is less than 90 degrees. So it's between 0 and 90. Then we have a right angle, and I'm going to actually fix that a little bit. But we have a right angle is the next one. So measure of angle A is less than 90. We have a right angle, which is, I'm sorry, I don't know if I just said that correctly. An acute angle is less than 90. A right angle is 90 degrees exactly. And you see that right here. Then an obtuse angle is going to be greater than 90 degrees. So yes, it is less than 180, but this is the part of it that I would focus on is it is greater than 90. But yes, of course, it is also less than 180. And then the last one we have is a straight angle, and we're going to need that for today. A straight angle is basically a straight line. If you measure all the way from one side to the other of that angle, that is 180 degrees or half a circle. So either way you want to think about it, that is 180 degrees and super important to our lesson today. All right, then the next part we have at the bottom is, sorry, I just want to recircle this a slightly different way because I'm crazy. So we have different types of triangles. And again, you guys did the different triangles in the previous video. So we have an equilateral, an isosceles, and a scalene. The scalene, that is the one with 3 different side lengths. That's why they are marked with different tick marks. So the first one has, or one of the sides has 1. This side has 2 tick marks saying it's different than the other one. And then the 3 tick marks saying that is a third different length. So an isosceles triangle, that's the one that has 2 of the sides that are the same, and you can see those marked right here. This side is the same as this side. If we wanted to mark the third side, we would do it with at least 2 tick marks because it does not match the other 2 sides. And if we know the 2 sides of an isosceles triangle are congruent, then we also know angles. We'll talk more about that later. The last one, I'm kind of going backwards in the order, but is equilateral. And that one, you can see all 3 sides are marked with a single tick mark because they are all the same. Also, they are marked with single arcs for each angle. And they even wrote in for us that they are 60 degrees. And just a quick word about that from what we learned yesterday, we know all the angles in a triangle have to add up to 180. And then also, if I need all those angles to be the same measure, then I know the total has to be 180. If I divide it into 3 equal parts, that's how we get the measure of the angles. I did not write that very well. Sorry. So 180 divided by 3 does give us 60 degrees, which is how we get the measure of each angle. And an equilateral triangle must be 60. All right, so that's just kind of a quick review of stuff that we've already mostly talked about. Let's go ahead and, of course, I'm very unhappy with this it just looks messy to me and I'm so picky. Okay, so that was 180 divided by 3 equals 60 degrees. Okay, then we're going to do a problem that's going to apply what we have learned about the triangle sum theorem. So answering that essential question, how can we apply it? We learned yesterday, day before, that all the angles of a triangle add up to 180 degrees. So the question here says find the value of x. This x, we're going to ignore that for a minute and just look at the triangle. We know 2 out of 3 angles in the triangle. I'm going to call, this last angle, I'm going to call it, we'll call it A. Call this angle A. Okay, so I can take a triangle, even though it's not what the question is asking me. I can look at something I know all the angles of a triangle add up to 180 degrees, and I can do some math here. I can say 63 plus 86, and that gives me 149. Then just like we did with triangle sum, I can say, okay, those are all the degrees I've used up. What's left over? And when I do that math, I get, looks like 31 degrees are left over for angle A. So the measure of angle A is 31 degrees. Great. I haven't answered the question yet, though. The question was, what's the measure of angle X, or what is X equivalent to? So if I go back a slide for a minute and look at this one, straight angle. A straight angle or a straight line, the whole thing, all the way over, has to be 180 degrees. So that means from where angle A starts all the way over, including X, this has to be 180 degrees. So with that knowledge, I'm going to say, well, let's see, if the whole thing is 180 and I know angle A is 31, then I can do a simple subtraction and say 180 minus the 31 degrees I know from angle A. And let's see, if I do some quick math here, this would become a 7, and sorry, a little bit messy again. I don't like the messiness. Try that one more time. Okay. Hopefully this gives you a little bit of time to write it down. Fantastic. So I have 10 minus 1 is 9, 17 minus 3 is 14, 149. So I get that X equals 149. All right, so we used triangle sum to help us figure out the angle X. But there is a fancy theorem that can actually help us shortcut all the work we just did and do it in one step instead of like 3 that we did. So what do you notice about my answer and the work along the way? So this answer came from here. That's how I got it. Where else do we see the number 149? We see it over here. There it is, 149. It was the result of adding the 2 angles that were far away from the straight angle. So far away from the one on the outside of the triangle, it's far away from that one. So we had these 2, when we added them up, it actually ended up equaling the angle that we wanted to find. So we're going to use that to talk about exterior angle theorem. So exterior angle theorem is the sum of the 2 interior remote angles, which are these 2. These 2 that are far away from the outside angle. When you add those up, it is equal to, this is going to be nice and long, the measure of the opposite exterior angle, which is this guy right here. Write that a little bit nicer. So if I take the 2 angles that are far away within my triangle and add them up, then when I add them up, it's going to equal that outside angle that creates a straight angle with the other triangle angle. So essentially what we're getting at is the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So the 2 angles inside your triangle but far away, they're called remote interior angles, because interior meaning inside, remote meaning far away. Those are equal to the outside angle, the exterior angle. Okay, so example 2. We're going to find the measure of angle 1. And here we go. Using our exterior angle theorem, we can take the inside far away angles, and we can add them up. So 47 and 61. And that's going to give me 108. Then that answer right there is equivalent to the outside angle, angle 1. So I would say the measure of angle 1 is 108. So much faster than how we did it in example 1. All right, example 3, same kind of thing. Again, take the far away one. So I want to find angle 2. This is the one I want to know. I take the angles that are far away, which would be the 24 and the 34. I'm going to add those up, 24, 34. I get 58. And so the measure of angle 2 is 58 degrees. Let's go forward. Let's see how we can make it harder. Of course. Oh no, they took the numbers away and now we have algebra. Of course. All right, but we're going to do the same basic idea. We know the the far away interior angles. When I add those up, so I'm going to say 5x plus 2x plus 6. Those are my two inside angles. They're going to equal the outside angle, the one out here, exterior angle, which is 8x minus 11. And just to clarify that one more time, that was one of the inside remote angles plus the other inside remote angle equals the outside angle. All right, so then we get to practice some solving equation skills. I'm going to combine like terms. I get 7x. 5x plus 2x is 7x. Plus 6 equals 8x minus 11. At this point, you have some choices about what to move where. I like to put my x's together first. So I'm going to move my 7x to the other side. I also typically prefer to move the smaller x, so 7 was smaller. That's why I chose it. But it's up to you. You can move things in any way you want. So 8x minus 7x is just 1x or x. And then I would, to get x by itself, do the inverse of subtracting 11. I would add 11. And I get x equals 17. So answer for number 4, x equals 17. And I check my directions, and it does say find the value of x, so we are done. All right, example 5. This one, we're going to keep working through it, trying to use the exterior angle theorem. Be careful that you always pick the remote interior angles. So they want me to find angle D, which is here, which means my remote interior angles are the ones that don't touch it. So it's these two. So if I was just going to write an equation, I would say x plus 51 equals the measure of angle D. But that doesn't help me figure it out because I still have two things I don't know. So we're going to go back to what we learned before. I have a triangle. What do we know about all the angles in a triangle? They add up to 180. So I can take the two angles I do know. I know 51 and 42, and I can add them up. I get 93. And then I can subtract that from 180. And let's see, minus 93. And I get, looks like 87. So 87 degrees would be my x. This is what my x equals, 87 degrees. Great. At that point, though, remember, I still haven't answered the question, what's the measure of angle D? But now that I know that x is 87 degrees, then I can do my exterior angle theorem, which says, hey, basically, we're going to add them together. So I'm going to say 87 plus 51. And that's going to give me my answer. Once I add this up, I get 138. So the measure of angle D is 138. If I could write it, that would be fantastic. 138. And there we have it. Are there any questions? Oh, you can't ask me because we're recording. Great. Well, let me know. Hope that went okay for you guys. and we will see you later.